world, and what does the moon look like for them. So, Vicky? So, astrophotography is very popular, and we did a workshop on that. Next. So what we try to do is take our winners to some site where they can explore a space center and do other related activities. So every year we try to make that the winning, the felicitation for the winners, and that brings us here today for the last 2 years. But previously we have gone to Dubai and to Singapore, and we've been really trying to make, to take our students to our own ISRO, because there's, ISRO has been, having achievement after achievement, and we all enjoy hearing about it all the time. And this is our chance to bring students to an ISRO center, and that is why we are all here today. So these are highlights from previous years. So with that, I also want to share that recently ISRO put out a call for space tutors. So I'm very happy that now ISRO is encouraging space education by, they put out a call for people who are doing the kind of things we do to spread the word more, to disseminate astronomy to the public and to students. And through that call, we have also got selected. So now we are officially affiliated with ISRO as space tutors. So with that, everyone, I welcome you here as a part of the NAC felicitation for not just this year, but for the previous year too. So I welcome 2 years of champions here today, and I hope you all enjoy the engagement and the, getting ready for the Olympiad, as well as participating in the Olympiad. So with that, thank you and welcome today for the felicitation.
Thank you, Dr. Mila. This was very, very interesting to see the kind of work that STEM&Space has been doing. And one of the things that I noted was, the event is called NAC, National Astronomy, and we have many international winners. So you can see that the unusual times also bring unusual opportunities, and the unusual times that we have seen, perhaps no other generation, should ever see that. The pandemic that we had, took the NAC to INAC. I don't know how it would be, named in the future, but that's the kind of opportunity one should make out of any adverse situation. And scientists are the ones who, take a lead there. Now, I'm very, very humbled, and I'd like to share that I tried my hands at physics myself in Delhi University, but then I realized, that the magnetism outside was too much for the magnetism that I thought I had, and I moved to business studies. But glad to be in the company. You can't be away or far from the scientists, so to say. Okay, so what I would now like to do is I would like to introduce our chief guest, for the evening, and I am very, very pleased to welcome Dr. K. Rajiv, who is the director SPL VSSC. He is the director of the Space Physics Laboratory, VSSC, and a specialist in atmospheric and space sciences. He obtained a PhD in physics from the University of Kerala and was a postdoctorate research physicist at the University of California, San Diego, USA. Presently, he is the Indian representative to COSPAR Council and member of the Research Advisory Committees of the Indian Institute of Geomagnetism, which is IIG Mumbai, and Indian Institute of Tropical Meteorology, IITM Pune. National Atmospheric Research Laboratory, NARL, Tirupati, and Cosmic Ray Research Laboratory, CRL TIFR UT. He is a corresponding member of the International Academy of Astronautics IAA and has published over 70 research papers in peer-reviewed international journals. That's a tremendous achievement, sir. 5 research is obtained, PhD under his guidance. He is ISRO, the topics include ISRO and NASA Earth Observatory, released news items on his research findings on aerosols, clouds, and radioactive impact. So that's a wonderful, wonderful achievement and a tremendous opportunity for all of you to hear the scientist who makes India proud, and this should be an opportunity for you to not only follow his footsteps, but learn from him how to do even better than him. Welcome, sir. I will welcome you.
Good evening to all of you. I'm very happy to interact with the future generations who will be shouldering the responsibilities of going to space or other aspects which will be in the cutting edge technology. And talking to students are always very dangerous things because they have no inhibitions. They ask any kind of things. So if I know something, I will tell you. If I don't know, I will say I don't know. Firstly, I am not an astronomer. I am a space physics or atmospheric scientist. With the firm foots on Earth, I don't leave Earth. I haven't left so far. But of course, as you know already, what we do with other planets or with other systems is what we learned from Earth, including the development of satellites or payloads or immersion techniques or mathematics. I like the word STEM because science, engineering, math, they come together, and actually a single thing, you may be a master in one of them, maybe physics, but physics is again a very vast subject. There you will be specializing in probably superconductivity or maybe quantum computing or in any other subject, theoretical physics or space physics, plasma physics, astronomy, a variety of topics. However master you are, you will never be able to do things on your own, with your own expertise alone, if you want to do something meaningful. Simple example is you want to observe something from space. First thing what is required is idea, what to measure, how to measure. That much will come from you, probably. And now the formulations are basic design. Maybe you will have to take on something. Fabrication, design, fabrication, testing, probably an engineering job, but you have to be again on the lead as a physicist or as a scientist. And then doing the inversion. You are getting some radiance which is observed by something to your detector. And it never comes as radiance for it. You know radiance. Radiance means the number of photons that are coming from one particular location in a particular direction. You have to invert it back to a geophysical product or an astronomical product. What you see in astronomy are images. Sorry, they are not the ones which astronomers use. There's a core inversion that is involved. You may be fascinated by the figures, but they're all graphics. There's much, much more than that if you really want to do astronomy. Right? Let me first introduce you something on Earth, and then probably I'll bring India's facilities to do that, because India has changed quite a lot over the decades. When you come to the Earth's atmosphere and space, the top right figure shows the photographs of Earth taken from the moon by Apollo. Such a fragile planet, and today we are disturbing it. Each one of you are responsible for that. The light that you use here necessarily is produced through some process where carbon dioxide is emitted. Without carbon footprint, you will not be able to have any of your luxuries or even basic needs some of the time. Each carbon dioxide molecule which you will liberate to the atmosphere is going to be there for next 30 to 100 years. You cannot do anything with it. It will be there. And you stop producing carbon dioxide today, the atmosphere will still warm for another few decades. You cannot do anything with it. Sea will rise for another 100 years or more. You cannot do anything with that. What you did is what you did. You cannot undo that. There are several things which comes through feedback. I am not going to the complications since the kids may be involved in this. Next. You know, I don't know, some of you may be believing in God, some of you may not be, some of you may be core scientists who think that everything is by the fundamental principles, and then you talk about it. The unique position is that it is not too close to the sun, then it would have been very hot, like Mercury. It is not too far from the sun, like, then it would have been very colder, like, for example, Neptune, Pluto, or other planets. It is aptly kept at a place which is 150 million kilometers from the sun. It has a meaning. Water can exist in three places. It's primitive. It's most important. Why water is so important? Water is important for taking bath, cooking. But water is the agent which transfer energy from one place to another. It plays a very pivotal role in regulating the temperature as on today. And what is that, of course, carbon dioxide also do. What is more important is it takes the energy from here and dumps it in another place. Simple example. Equatorial region. If you look at Earth as a globe, maximum amount of solar radiation comes at the equatorial region. Obviously, equator gets warm, and we keep on getting warming. And I should also tell you, those students, the principle of night vision camera. Each one of you emit radiation, like sun. Each one of us are like sun. Sun emit radiation at a particular wavelength that we call visible wavelength, because solar temperature is of the order of 6000 Kelvin. Your temperature is 300 Kelvin. So you emit something in the infrared, which your eyes will not be able to detect. But if I can have a device that is called infrared sensor, I can imagine. This is how night vision cameras, thieves are getting caught. It's a fundamental principle. It is the same principle that is used to observe clouds throughout the day, both day and night, because in the night you don't have solar radiation. So it is the same principle which is being used. What I am trying to tell you is another, that Earth emit radiation. Each one of us emit radiation, like that Earth emit radiation. There's an energy balance that comes between what you receive from the sun and what you emit. There's an absolute balance, and that we call top of atmosphere, means Earth atmosphere system. Any imbalance in that will be balanced at the top, but it will not be balanced between the Earth and the atmosphere. Together it will be balanced. What does it mean is, today, I'll come to that figure. Before that, let me tell you about the water. So the heat that is getting heated in the equatorial region has to be transferred to the polar regions. How does it transfer? It evaporates from the surface. Water evaporates from the surface. Can be soil moisture, can be ocean. Takes latent heat of evaporation, takes it to the atmosphere and get condensed. It transfer the heat from here, and where clouds get formed, that is the place where it condenses. Complete energy is transferred. No energy loss. At times, clouds will not be formed at the place where you have the evaporation. Rather, it will be spread horizontal. It will go to thousands of kilometers away from the place where water vapor is originated. And that is, this is called the transport energy from the one region to another. In the absence of this, that would have been very hot at the equatorial region, and it would have been extremely cold at the polar regions. Much more, differential heating than you expect. Then what would have happened? It would have been extremely windy, because the temperature contrast controls the pressure contrast, which controls the wind speed. It will not be hospital. Next slide. You know, Earth atmosphere protects you from various things. Earth atmosphere gives you oxygen, of course, you have to inhale, yes. Earth atmosphere, protect you from millions of meteors which are entering the atmosphere every day. How many of you have seen meteors? Everybody? Yeah. These meteors you see because they enter into the Earth's atmosphere with a minimum velocity of 11.2 km per second. The escape velocity of Earth. If a body wants to escape from Earth, it has to be 11.2 or more. That means if it is entering from outside, its velocity will be 11.2. Maximum of the order of 72 km per second, that is the combined escape velocity of the Sun plus that of the Earth rotation. A body coming at 7.2 to 72 km per second, when it enters in the atmosphere, it will have friction. And that friction will get it heated. Heating will ablate it. That ablation is what you see as the shooting stars. This happens not here, not 10 km, not 50 km. It happens at 100 km or even above. And what you see is shooting stars, which are very big. There is something called meteors, micrometeors. They are microgram size. You just go to space, these particles, not only micrometeors, the bigger particles also. And because these micrometeors come and fall there, lunar surface is very fluffy. We call it as regolith, lunar regolith. First 50 centimeters of moon is very fluffy. And it is that fluffy thing, because of that you are able to see the footprint of the people who have landed there. Otherwise you would not be able to see it. So atmosphere protects us like this. Before that. There is another important thing which at least some of you may be coming to become Survey Space Center tomorrow. Why BSSC? You see this? This is Earth. This is a magnetic field around Earth. Earth has a magnetic field. It should have been like a Pakka dipole. You know a magnetic field. But it is not like that. It is compressed here and extended here. Because sun emits not only radiation what you see here, sunlight. Sun emits particles. Particles means protons. That is
Light particles.
Yeah. Light is different. That's what we say the the radiation what we say. The other is particles, that is protons, helium, and sometimes to a smaller extent calcium and things like that, but their concentration is very small. They travel with a velocity of the order of 300 to 1200 km per second. In 1 second, almost 1000 km. When a charged particle moves, it will produce. It is like a current. A current will produce a magnetic field. So solar magnetic field comes along with that. You have Earth's magnetic field, solar magnetic field. These two things interact. And on one side you have the compression, and the other side you have an expansion. One more beautiful thing happens. It doesn't allow these particles to directly come to the Earth's, the place where we are sitting, because magnetic field prevents the motion of any charged particles across it. It will deflect it. It will deflect it in such a direction that it will be aligned along the magnetic field. While it is going, it will not be straight. I am not going to the details. It may do a spiral shape and things like that. And it will precipitate at the polar region. It can travel along like this and then precipitate the polar region. That we call aurora. Aurora borealis, aurora australis.
Yeah.
These things may appear to be very funny to see it, but it provides a beautiful avenue to study upper atmosphere. And it is also important because there will be power outages in the high latitudes. Complete power outages in Canada can be also part of US and things like that. If there is we call solar storm. She is a master in that. I'm not an astronomer. All right? But then these kind of things do affect it. The third aspect is, we may be thinking, the atmosphere is all dense here, but the life of you and me are not protected just by that, but by the very thinnest atmosphere, hundreds or thousands of kilometers away from us. There also atmosphere is there. And that is actually space science. Studying that is space science. Next. Why should you study that? You know, as a scientist, obvious answer will be, I want to understand my environment. Unless I understand the environment, I don't know what to do with it. That is okay, that everybody says. But what is more important is, as she was telling, he was telling, there has been an application for everything. Otherwise, why should you study? You solve a differential equation for the sake of solving differential equation. What is the fun in it? After some time, you may get 100% mark in mathematics. That's all. Unless you are able to apply it somewhere, it doesn't have any use. So that means, once you understand the system, you have to have some application. The readily available application, I did not list the complete application. The readily available application to use weather prediction. What will happen tomorrow? What will happen after 10 days? All over the globe. You know, there's an area called the fluid mechanics. This is nothing but fluid mechanics. Mechanical engineers use it left and right. Atmospheric scientists use it left and right. Any fluid mechanical fellow, fluid mechanics need not be just purely fluid mechanics. It is magnetofluid fluid dynamics. There are various areas that comes up. Alright? But you should be able to forecast. There's a difference between weather and climate. Weather is what you face today. Climate is an average of the weather. That means after 100 years, what will happen here? Do you know that after 100 years, there will be significant sea level rise, and the sea level will be rising? Estimate is of the order of 40 centimeter to approximately 80 centimeter. Most of the population which live in the coastal areas will be affected. There may be submerging, islands can be submerged. Let me tell you another aspect. The place where we are sitting, of course it will not be there at that time, like this. After 50,000 years or 1 lakh years will be icy. It will be icy here, right here. It's called a long-term climate change. There's a natural and there's an anthropogenic. Next slide, please. The third thing is science. You know, one of the ready application is all of us use mobile phones to, go to places and then locate. I am not going to the principle of GPS and all those things. But one of the things that is required is correction for the atmosphere, where you have intense, electrons and, ionized particles, which will affect the way in which radiation passes through you. That need to be corrected, otherwise your mobile phone will be wrong. As far as we are concerned, it doesn't matter to come to this hotel, even if it is 2 meter or 10 meter away, it is okay. What about the aircraft in which you are going to fly, and the pilot is going to be an autopilot and going to land? And it is going to happen now. It is there. It is there now. So it needs to be corrected for. If you want to correct it, you have to understand what is the space, what is the environment, and how to do that. And this is what you are going to see tomorrow. Tumba, this is the place where you are going to visit. And it is a Tumba because of a reason. You have a magnetic field, I told Earth's magnetic field. At one place it is horizontal to the Earth's axis. That is sort of a, I will put it as a plane. It's something called equator. It is not geographical equator, it's magnetic equator. Magnetic equator passes through very close to Tumba, maybe a kilometer. Now it has shifted. It is shifting. Now it has slightly more shifted. And this is the building where you are going to see tomorrow. That is the Space Museum. All right. Next one. Can you put the next one? What is the total extent of atmosphere? People may think atmosphere. Okay. Once you go around maybe 8 kilometers without having a proper air for inhaling, you cannot sustain. All right. But atmosphere doesn't end there. Atmosphere ends to thousands of kilometers away. Satellites are getting dragged by that atmosphere. You have to correct for that. The satellites should carry fuel to overcome the drag that is offered by the atmosphere. Even at 1,000 kilometers, even at more than that. All right. Next. Incidentally, one thing which I will tell you: each one of you carry around 400 kilograms of air in your head, which is much more massive than your own mass. You will crumble, but you don't crumble because every molecule wants to come to the surface, but because of gravity, it pulls it down. But every molecule wants to go from a high pressure to a low pressure. Here pressure is very high, their pressure is very low. Now there is a balance between them. It wants to come down, this fellow wants to go up. That is called the hydrostatic balance. Because of that, you are not phasing. Otherwise, 400 kg in your head, you would have been crumbling. Next. So atmosphere looks so thin, It's only very, very shallow, but it is not. The space above that is more important. for some of the things which we are, using, like satellite systems or things. Next. And atmosphere is always in motion. There's a thorough, systematic movement. And let me tell you one thing. If you clearly observe, that's a cyclone getting formed and dissipated. It's a spot in this map. But that cyclone creates havoc over probably a continent. And it will have a total power that it liberates is much more than maybe hundreds of atom bombs, but over a time. Next. Upper atmosphere is highly, ionized. If you go to around 100 kilometer or 1000 kilometer, atmosphere is highly ionized. We call that plasma. All right. Next. And all what we do, if I take an altitude and the activity, you have the space shuttle kind of things which are up in the atmosphere, maybe 300 kilometers and above. But in the lower atmosphere, you have airplanes and things like that. Variety of systems, variety of environment you face. This is the case with any planet. You go to any planet, this is the kind of thing which you are going to face, depending on, how far you are away or close to the star. This is similar to something which will happen. Next. This is actually, I told you in the beginning, climate change. You are getting radiation from the sun. You are using it for, the food that you are just taking came from the sun. It is not manufactured here. Sorry, it came from the sun. If sun was not having radiation that is giving to produce this through, your photosynthesis and things like that, you would not have it there. And the earth emits. There's an imbalance in the atmosphere. As far as energy balance is concerned, earth receives more than what it emits, atmosphere emits more than what it gets. There's an imbalance. This imbalance is counterbalanced by clouds, development of convection and things like that. If that imbalance was not there, cloud would not have been formed. There would not have been any rain. Next. But we are perturbing it. There was a balance. There was various components. I did not explain all those things because time is very short. But you are changing it. A lot of aerosols are being produced. These aerosols are black in color, can be white in color. There can be natural aerosols, there can be anthropogenic aerosols. Black carbon, that we call soot, is the most dangerous one, which will heat the planet. Next. Actually, you can have a very detailed analysis of the aerosols. It's a very, very complex process. Okay, next. There can be natural processes by which aerosols are produced, like volcanic eruption, mineral dust, things like that. Next. There can be anthropogenic things like oil burning. It will modify the clouds. These aerosols will modify the clouds, and your precipitation, the rainfall pattern, everything will get changed. Next. And carbon dioxide is increasing. You look at here. See, the carbon dioxide level was of the order of 300 or 310. It's called a toxin unit in around 1960, and it is monotonically increasing. 2010 value was of the order of 390, and today's value is of the order of 420. Toxin unit. And pre-industrialization, before the much of the anthropogenic activities were going on, its value was less than 300. So you and me added around the 300, around 110 units to the atmosphere. And you are perturbing the climate through that because carbon dioxide is a greenhouse gas. Next. But carbon dioxide has a lifetime. After order of 100 years, it will come back if you are not emitting anything further. Aerosols, it has a lifetime. After order of a week, it doesn't. An aerosol that is produced here cannot be transported to thousands of, not thousands, okay, but maybe tens of thousands of kilometers away. It will be regional. But there is another problem. There is something called Milankovitch cycle. Astronomers know it very well. Over a period of 40,000 years, 1 lakh years, and 20,000 years. 20,000, 40,000, and 1 lakh, approximately. There may be 1,000 year difference. Earth's eccentricity changes. It goes around the sun in an eccentric orbit. Eccentricity changes. That means you will start getting more radiation and less radiation, more radiation, less radiation, over a period of 1 lakh years. The axis 23.5 is not 23.5. It changes from 22.5 to 24.5. over a period of 40,000 years. 23 and a half can be this way or this way or this way or this way. It changes over a period of 20,000, approximately 20,000 years. All these things will change the amount of radiation that is coming to you, the heating that it produces, generation of ice. Let me tell you the beauty of physics here. I'll take only 2 minutes, with your permission. You will not survive for 1 lakh years. You were never knowing, humanity was never there for 1 lakh years, 50,000 years. How do you know all these things? That's the beauty of astronomy. Astronomers know all these things. You don't have to live for 1 lakh years, but you can predict certain things. I'm not an astronomer. Second, Earth has written its history. Question is, can you read it? We are all illiterates. We cannot read it the way we think. But Earth has written its past very well for lakhs of years. It is there. Alright? Only thing is, you have to devise a technique to read it. That's called the paleoclimatology. Simplest example I will tell you, very, very simple example. What was the kind of temperature prevailing here over maybe 5,000 years? There are some trees which survive for hundreds of years or thousands of years. Each year there is an annular ring that is formed. If you cut a tree, even maybe 10-year-old tree, you will find annular rings. The annular rings are formed because the growth of the tree. The growth condition depends on the prevailing climatology, the prevailing rainfall pattern, the prevailing temperature, dryness. Question is, can you convert it to temperature? Can you convert to precipitation? People have devised the techniques. Over 1 lakh years, how do you do that? You go to ocean, deep sea drilling. Every year there will be pollens and things like that which will be going from here and to the ocean. It will be deposited there. Then dry season comes. Then again wet season comes, it will be transported. Layers of pollens get formed. The more you go deeper, the more you are going back in time. Similar is the case with the ice caps, because air gets trapped in the ice and then no reactions take place. If you can drill maybe a kilometer down, you are going back by more than a few lakh years. Next. This is called a Milankovitch cycle. That's what is explained here. Okay, next. Can you go to the next? Okay. Now, the question is this. Milankovitch cycle will change the temperature. It will become icy here. You have nothing to do. You like or not, it will come. But there's a problem. It comes or it goes very fast because of your action. Because nature never had altered the climate so fast. It altered it over a period of 1 lakh years. It altered over a period of 20,000 years. You are altering over a period of 10 years or maybe 100 years. And what is going to happen? This is the history from 1900 to 2000. And this is the forecast. At 2100, what is going to happen? This is actually the global surface temperature. It is going to warm. It is going to warm by almost 1 degree centigrade to around 4 degrees centigrade. And I don't know how many of you can survive if the global temperature increases by 1 degree centigrade. It is not the question of 33 become 34. Huge chain effects will come. Next one. Even if you stop everything, look at this curve. Sea level will rise. Period is 4,000 years. Because of the effect of what you did, the sea level will continue to rise even beyond 1,000 years. How do I say all these things? From basic physics. One of the fundamental physics why sea is expanding. What is the density of water? Variation with the temperature. There's a minimum and then it increases. That means if it is getting warm, density increases. Ocean will expand. Sea level will rise. It's logic. Next. To do all these things, do you have techniques? Yes, we have. And I am focusing on India. Do we have techniques in India? Enormous techniques. Enormous technique. And India is one of the richest countries as far as these kind of scientific advancements are concerned. For example, for Earth atmosphere monitoring, I am not going to space here. You have satellite systems dedicated for this purpose. Dedicated only for the purpose of atmospheric space research. India has. You have network of observatories spread all around the country and over the ocean. You have aircrafts equipped with, sophisticated instruments, goes, flies, measures, and come back. You have dedicated ships. It can go to any place, Antarctica included. You have ocean buoys. You have, when you combine all these things, you have glaciers, observations. To combine all of them, integrate it, STEM comes in there. Correct? It's actually really STEM. Actually, put it the other way, it is called the system engineering. All right? Systems of systems. If you integrate together, assimilate together, you will be able to know what happened, verify your prediction, and go for the next. Some of the mammoth facilities, unbelievable, even in very advanced countries. We have a facility in Hyderabad that is called the Tata Institute of Fundamental Research, high altitude balloon facility. 1 ton of material can be lifted to 40 kilometers, and it can float based on what you want, and bring it back, controlled. 1 ton, which is, I think most of the cars may be weighing less than that. To coolly take to 40 kilometers and bring it back. You have satellite systems, rocket systems, OT telescope, radio telescope. World's biggest nuclear telescope exists in India, in Pune, GMRT. Alright? So, the other systems. India is very rich. India is very rich, opportunities are enormous. And foreign people want to shake hands with us because of the advancements that we have. Next. Next. Okay, I will not dwell much on that because of lack of time. Next. Keep going. We have a dedicated satellite just for atmospheric observation. It's not for weather prediction. Something called mechatropics. It was an Indo-French mission. India and France came together. Next. There's I don't know, the figure you may not be able to see it very well. This is a huge antenna system running into acres of land. And that is to observe what happens at 90 kilometers, 100 kilometers, 1000 kilometers. This is the second largest facility in the world. It is at Tirupati, National Astronomy Research Laboratory. Designed and developed in India. No foreign collaborations. Absolutely nothing. Next. The GMRT is state-of-the-art system where even most of the countries in the world don't have this kind of a facility. It is astronomy. It is for astronomy. Next. I told you earlier about the satellite navigation where your GPS data will be corrupted. It needs to be corrected. India is having its own GPS system. It's actually GPS is American, the global positioning system. India has its own system. It's called NAVIC. Okay. ARNSS system, where you have a cluster of satellites, 7 satellites, and that will be able to give you much better accuracy continuously over the Indian region, but only over the Indian region. It will not go to the next. Next. We are going to have a mission now to move to the sun. It's called Aditya. It will not go to the sun, but it will go around 1.5 million kilometers, that is around 15 lakh kilometers from Earth towards the sun. And it is going to monitor the continuous state of the sun. The Chandrayaan-1, she has already mentioned that you are doing some experiments, some of you. The data is already available in the public domain. Those of students who want to use it can use it. Next. Discovery class results. Discovery of water on moon was the first of its kind in the world. Now, after India discovered water on moon, you look at any mission that is going to moon, one of the primary importance is water on moon. Not India's, all other countries. India was the leader. Chandrayaan-2 data is again available, orbiting at 100 kilometers, mapping the moon, as well as measuring the atmospheric constituents. Moon has a very, very thin atmosphere, very thin, very, very thin. You cannot inhale anything there, but it is there. Next. There was Mars orbital mission, which for observing the state of Mars. Next. This is some of the images from that. Next. And this is astronomy. We all know Hubble telescope, we know James Watt. How many of you know AstroSat? And the core scientists who are in astronomy knows what is AstroSat and the power of it. It produced discovery class results. I repeat it, discovery class results. including detection of light 9.5 billion years away from you. That is one of the farthest that any telescope has detected. I'm not an astronomer, so I'll not be able to tell you much on those things. Next. So thank you. This is actually the space science, which is real STEM. All right. So thank you very much. I did not dwell much on astronomy. I expect that Anand will come and then talk to you, but Mila is sufficient enough. I don't know how many of you know her credentials, just for 1 minute. Her father, how many of you know by name? Nobody? His name is A.P. Vedant. He was the dawn of Indian science and controlled I will say, fully controlled the Indian science, space and atmospheric science, for a period of maybe over 50 years, and was very close to Nobel Prize. I had a personal interaction several times with him. When I was doing my postdoc in US, he was there that time. I told him. And up to that time, he is in the sky and I am on the ground. We couldn't meet, so we met in US, where we could talk. All right. So he's such a giant. And the moment she called me, and the introduction was Mitra's daughter. Actually, that that speaks for it. And she herself had an excellent career in astronomy. So all your astronomy questions to her, not to me. Thank you.
Wasn't that awe-inspiring?
Yes,
It was? I need to hear it then.
Yeah. Yes, sir.
This was an eye-opener, sir. Really appreciate your taking time this evening and kind of, I have those pimples, seeing that there's so much we've done and we should be held responsible and we should be doing something about it. Will you be doing something about it?
Yes, sir.
Excellent. Your mission is now being taken many more in this room, and they are very true to their word, sir. Really appreciate it. And there are a couple of other things that I learned. Learning language skills. She is now fulfilling her ambition with the release of an interactive app, Phonetti, and is currently here to promote the release of the platform in India. So India would benefit from a very unique patented technology that she and her team have developed.
Excuse me, sir. So there's one.
Okay. Kim is also the inventor and founder of Tafood, that is an award-winning food tech which works extensively across the food, service, health, and education sectors. She's passionate about food, allergen awareness after her husband's near-death experience over some bad allergens which were the result of some food that they ordered through a menu in 2013. So again, a big lesson that something that impacts you, rather than being overwhelmed by it, you should try and find a solution which would not only solve your problem but also solve problems for others. And that is what scientists do every time they are trying to find natural solutions. And that's what I would urge all of you to do. Before I invite Kim to speak to you, must say that I had a great time to be with her this afternoon, and she is very, very adventurous. We had a three-wheeler auto rickshaw drive 30 kilometers away. So anyone would have thought that I tricked her into an auto rickshaw drive, but then it was a two-way. So that's the kind of adventure that she exhibited, and there are a lot more which I will share with you over a period of time. But now it's over to Kim.
Namaste. It's lovely to be here. I have to say, I'm not sure why I'm on this stage after Dr. Rajiv and Dr. Miller, because what incredible, intelligent and inspiring people they are. I'm really here to talk to the kids. I want to talk to you children, and I want to talk to you children about having a can-do sort of feel about life, knowing that actually, if you put your minds to it, you can do anything that you want to do. The fact that you're here today, and the fact that you have all been finalists in this phenomenal competition, which I understand had thousands and thousands of entries, shows that you're already children that, you know, believe in yourselves and have got an ability to kind of have the courage of your convictions. Let me tell you a little bit about my story, if I can. So basically, I'm a mum and I'm a granny, and I've got children, a couple of children that are quite heavily dyslexic, so they've got reading difficulties. They're both all grown up now with children of their own. However, when they learned to read as a child, it was always a bit of a struggle in our house because with their dyslexia, you know, conventionally picking up a book was always quite difficult for them. So it was, I mean, they're in their 30s now, so they're all very grown up. But it was an incident with my grandson, who's now 12. About 10 years ago, he was 2 years old, and he was in the car with me, he was getting a little bit bored and fractious. So I gave him my iPhone, and I put Chuggington on, which is a cartoon that he loves about trains. As soon as the cartoon finished, he swiped. He swiped and he put the next video on. And this was a child who could not string a sentence together, yet he knew how to use the technology. And I put all of this experience together and thought, wouldn't it be great to build something where people could use technology, children could use technology to help them to do one of the most basic and important things that we're ever going to need to do, and that's to learn to read. And this is where that kind of can-do and entrepreneurial kind of attitude comes into it. Because I got together with my team and we thought about building an app where children would read aloud and somehow they would know how they would do it, because the words would change colour, or they would do something in real time to indicate that the children had got it right. Anyway, we had to go, we had to try, but we couldn't get the accuracy right. So it wasn't really viable, it wasn't commercial, we couldn't do anything with it. And then that's when I turned to technology in a big way. And we thought, what this actually needed was, it needed some voice recognition that was developed specifically for reading that would actually power the app and actually make it work. So we, instead of just saying, well, we can't do it, we're not going to get great enough results, we sought the best possible people to help us, the best technologists, and this is where the technology comes into it. So we partnered with the University of Edinburgh, and we actually created the world's first speech recognition engine that's been designed for reading. And that has culminated in this platform and this app called Phonetic that we're talking about. And one of the reasons that I'm over here, or the main reason I'm over here, apart from celebrating this fabulous event with all of you people, is because we've been working over the last year really with STEM&Space, working on a reading challenge. And the reading challenge basically was it's an app of books, literally it's a platform of books. Children will go on, they'll read aloud, and as they read, get the words right, the words will turn green. If they miss a word or get them incorrectly, then it just grays out. And at the end of it, they get a well done, and they get a level of accuracy and a mark for fluency. And one of the reasons why I'm actually in India is initially I thought that this was really all about how do we help children improve their literacy? How do you encourage children in a world where children are less likely to pick up a book and more likely to pick up a mobile phone or a tablet? You know, and I thought initially, well, if this was going to be something that was going to actually just improve literacy, surely we could extend this in a way that it would help practice the English language. Now, being in Trivandrum this last few days, I've realised that I always knew the vastness of India, of course, you know, the 1.3 billion people, wonderful people. I have to say, I have fallen in love with this country, absolutely. Well, even those rickshaws that I lived on all times today. One of the things I realised is that actually down in this particular part of India, they actually speak a very different language or a different dialect from a lot of the rest of India. So the common language, and this surprised me a great deal, is English. Everybody here has got some form of level of English, and it's become, it's obviously is a very common way, next to mathematics, of course, which is the most common universal language. And so I realised that not only to encourage people to become more literate, it was really important to actually help give a platform where children can practice their English. Every child learns differently. When you've been recently doing all of these, these challenges that you've done with STEM&Space and the NAC challenge, you've all done it, you've all approached it in a completely different way, but you've all got to the same result. You've all got to the point where you've won. You've actually achieved what you set out to do, but you've probably all done it very, very differently. You probably all communicate very, very differently, and I think that's a fundamental life skill, learning how to learn, but learning actually how to communicate as well. I think many times when you've come to a place, and I have to say, I've tried many, many times, I cannot pronounce the name of this territory that we're in. Trivandrum, I thank God it's got a shorter name. I just can't pronounce it. But what you tend to do when you're in a country or you're learning a new language is you're sometimes quite embarrassed to kind of say things in case you get it wrong. But actually, it really doesn't matter. It really doesn't matter because there are many, many, many universal ways to communicate. A smile is a simple way of communicating, a nod of the head. And I think that it's all just about, people communicating, people getting together and collaborating. This fine gentleman before me spoke about, there's a new way of doing things, and it is collaboration. And I think collaboration is really, really important. I can waffle and talk for English, I have to say. So I just wanted to really reiterate that with all of you children in the room, congratulations, you've done phenomenally well. And whatever you feel that you want to do, whether that continues in science and STEM, or whether it leads you into some other country, or wherever it leads you, have the courage of your convictions. Believe in yourself in the way that you believe in yourself right now, at this particular point in this time. You will remember today, probably not my talk, you'll probably remember the wonderful talks from Dr. Miller and Dr. Rajiv, but just remember how you felt today as a winner in this particular room on this particular occasion, and then go communicate that to the world. Tell everyone how clever and how brilliant you are and how proud you are. And I'm sure the people around you are every bit as proud. So my advice to you all, courage of your convictions. You can do and be anything you want to be, and you've proved that by already, achieving what you've achieved today. So, thank you.
Thank you, Kim, for being here and addressing the young budding scientists and the teachers who are accompanying them, and I'm sure there would be many who may be already teaching English. Awesome, thank you so much. And Kim talked about some 1.6 billion people in India, but the entire everyone here, I would think, knows that there are more galaxies, in the universe than the people, in the world, and India is helping the cause. So we will continue to grow and achieve. Yeah. All right. So now, after thanking Kim, I would like to invite Mila again to make a very, very special announcement. We wanted to, do this live, but Mila will share, the message with you. It's a very, very important message. Over to Mila.
So we will just end this part of the session and start the awards next. Um, I want to share a very special message. So has anybody heard of the golden record? Sir, would you know about it? So long back, Carl Sagan, it was his idea. So what happens if we want to connect with people if we want to connect with aliens? So if we send a mission, and that's what was done. That was the golden record 1.0. So the concept was that because now we have spacecraft that are getting to the edge of the solar system and beyond. So there was a golden plaque sent, and some of you might know about it. But what do you send on such a plaque? What do you try to convey about our world? So there were two figures. It was made of gold because gold does not erode easily. Then there were some languages. There were concepts of binary. So things like this that were thought that you can convey what our world is to an alien. So now there's a new project called Golden Record 2.0. And again, the concept is that what do you put on such a record that will convey our Earth? And as you can understand, this has political implications, archival implications, because these are our records. It might be the top languages, it might be the top discoveries, it might be the top music. So this project is now ongoing and led by an organization called Interstellar Foundation. And I'm proud to share that we have been selected to be their educational partner. So what that means is we will... So basically it's the concept of astrobiology. So that means where can there be life? What do we convey about life here on Earth? And things like this. And that is what we are going to take forward as an educational and outreach partner. And I hope all of you would be excited to join us. So today I have a special message from Nick Serra, congratulating all of you. And I was hoping he'll be with me on Zoom, but somehow he's not, so he may not have got the timing correctly. So I'm going to play the message that we already have from him.
Hi, I'm Nick Serra, the founder of the Interstellar Foundation. Firstly, I'd like to congratulate all of the participants in the National Astronomy Challenge. These projects are so very important to our future on this planet, and it gives me a lot of hope that you will be the ones taking us forward into the future. The Interstellar Foundation is currently making a new interstellar message. These are similar to the Voyager Golden Records that were on the NASA spacecraft in the 1970s. Those two spacecraft are the furthest thing away from our planet that humans have made. STEM and Space are also going to be our global education partners, so I do hope to meet some of you in the future and hopefully work with some of you in the future. Keep doing what you're doing and stay amazed.
So, and with that, I turn it back over to Chandra sir.
Okay, so now the much awaited evening, for which all of you have gathered here, the awards ceremony. And leading this ceremony would be your own very, very familiar person that you might have interacted with, Arjun. I would like him to come on stage. And one more thing that I learned from Kim when she addressed was that your words make the world, so make it a beautiful one. Over to Arjun.
Thank you so much, everyone. And as Professor said, it is not about me, it is about you guys. Right? This entire ceremony is about you guys, about what you have achieved. Right? So this National Astronomy Challenge, like Kim very well said, that believe in the conviction that basically that you can do anything, right? So here, what if anything you can take away from this, let's say, award ceremony or from this entire experience of National Astronomy Challenge? It's just one of many challenges, and unknowingly you were basically showing some characteristics, right? That is, you are passionate about it, you are dedicated about it, and you sincerely work to get on top. So if you can get these qualities intact, you can be successful in any challenges in future, right? So with this, let's just start bringing about the, let's say, the students, and let's just get the ceremony begin. So first we'll be calling on the stage the 2021 NEC winners here. Yes. All right. So yeah. So first, we will invite our chief guest on stage to give the awards to the students. So sir, please come on board. And now we would invite Kim as well. Kim, if you can also come on stage to give the award. Yeah, yeah, please. All right. So, okay. So starting with, like I said, we'll start with the 2021 awards first. And so the first one we are going to call is Pranav Sunni from CMR National Public School, Bangalore. So please come forward. All right. Okay. So again, all right. So 2020 first. 2021. All right. So as I got the request, we will be giving the awards to 2020 winners first. So again, now let me call Shrika Chedu from PSBB Millennium School, Chennai, and accompanying is Miss Reena Khan. So here, ma'am, you can also come up. Okay, so thank you. And next I'm going to call is Tasmay P. Jain from Royal Concord International School, Bangalore. Congratulations, Tasmay. So next up is Edna Nima Varghese from Delhi Private School, Dubai. So on stage, Edna. All right. Next up is Gautam from New Delhi Private School, Sharjah. Yes. Gautam Karunakaran. Next is Shashvat Singh from Indian School Al Wadi Al Kabir, Muscat, and accompanying him is Miss Jennifer Robinson. Congratulations. Next up is Ashmit Alok Kumar Sahu from Srimati Sulochana Devi Singhania School, Mumbai. And accompanying him is Ms. Anupama Ghosh. Alright, keep the spirits up, everyone.
Yeah.
So next is Diya Dadu from Shiv Nadar School, Gurgaon, and accompanying her is Miss Tina Sethi. Congratulations, guys. Next is Shashvat Nayak from Indian High School, Dubai, and accompanying Shashvat is Miss Malthi Mansingh. Great. So Shashvat. Next is Adit Kumar from Delhi Public School, North Bangalore, and accompanying Adit is Miss Sajna Mohan. So congratulations, guys. And next up is Anika Ghai from Somerville School, Noida. So give a hands up. Okay. Congratulations, Anika. Alright. Next is Rohit R from Chinmaya Vidyalaya, Kilpok, and accompanying Rohit is Miss Ramya. Alright.
We request ma'am to take.
Rajan sir. Yeah. So please, sir. Okay. And next, so next is Vedant Yadav from Delhi Public School, Nagpur, and he's accompanied by Miss Ritu Sharma. Alright, and so those were our winners of NAC 2020. Now, moving to the last year's NAC 2021, we have already given the award to Pranav Sunni. So, I'll call on stage Rajrishi Nanda from Delhi Public School, Raipur, and he's accompanied by Veena T. Okay, so next we have Satvik Bhatia from ECM Group of Schools, Ludhiana, and he is accompanied by Miss Ramita. Yeah. Alright, guys, keep your spirits up, come on.
That's good communication. Very good communication. An entrepreneur tomorrow.
Alright, so that was Satvik. Next up is Vedang Nair from Global Public School, Kochi. Congratulations, Vedang. Following Vedansh, we have Diptansh Rajshekhar from Vidya Shilp Academy, Bangalore, and following him is Prasanna Kumara. All right. Next, we have Prisha Bansal from Darbari Lal DAV Model School, Delhi, and following her is Ritu Mahani.
My handwriting is too bad.
Great, Prisha. And next, we have Pratyush Ghosh from Indraprastha International School, Delhi. Congratulations, Pratyush. Come on, guys. All right, great. So next, we have Shashvat Singh from Indian School Al Wadi Al Kabir, Muscat, Oman again, and basically accompanying him is Miss Jennifer Robinson. So Shashvat was a winner in NAC 2020 as well as NAC 2021. Great job. Yeah, so you can keep coming to Great, great. So that's amazing, Shashwat. All right, following Shashwat, we have Hariyansh Sitaram Pradhan from DAV School, Burla, and accompanying him is Shri Harsh Kumar Pati. Shriyansh Sitaram Pradhan, sorry. Yeah, come on, Shyam. Have a round of applause, please. Alright, great. So next, we have Milan Kumar Pati from Loyola School, Bhubaneswar. Next, we have Keshal Kamal from New Horizon Gurukul School, Bangalore. And following him, we have Nivedita Dasgupta. And then we have Hygreave Jayendran from Vidyashilp Academy, Bangalore. Alright guys. So with this, last but not the least, we have Swastika Sharma from the Air Force School, New Delhi. Oh, that's great. So yeah, so Swastik here is also a two-time winner. He also won in 2019 NAC. All right,
Vedant from ABS Nagpur. Yeah.
great, great.
He was.
Yeah. So with this, students, you all have received your awards. I hope you are happy about it. So yeah, let me call back CSP sir.
Oh yes, yes. Not only before. CSP was.
No, we won't let you go. And one of the things that you would have again learned, all through the award ceremony, both of our chief guests were as excited as if, they were giving the award to the first, child who won. So it was the same. So that's the other virtue, we all need to be successful in life, having a lot of patience, a lot of enthusiasm, and always motivating the other. Because when you motivate someone, you just don't motivate that person. You motivate a family, and when you motivate a family, you change, like they say, the environment or the atmosphere of the family, and then the society, and then the country, and then the world. So absolutely delighted to see your enthusiasm, both our chief guest as well as our special guest Kim. And now I would invite some of all of you who have won an award to take a group picture. So yeah, so first should I call 21? 2020. Okay, so 2020. Please be here, all of you.
All of you, the teachers,
Teachers also please come.
and the parents also. Yeah, please come.
So I invite again our guest, our chief guest, Dr. Mila Mitra on stage.
Okay. Dia.
The teachers will come and blessing the kids. Just be careful. All of them are able
Can you see the teachers also, or? Yeah. Or would you like all group of students stand below?
Everyone smile.
there's enough space.
Gautam, why don't you please
No, no, no.
The face will be overlapping, so keep it down.
Yeah, make sure that please don't cover your faces.
Yeah, yeah. So slightly keep it down. Ma'am, you can come this side if you want.
Can everybody please see?
Yeah. Alright, smile once again, everyone. Everyone, look at here. Smile, everyone. Look at here.
Thank you so much. Thanks a lot.
2021, Vedant, please come.
Thank you so much. It's there. Please do me a favor. Like this happens.
Yes, those are the super.
Come, some of
Sit. One sit.
Closer to the chair.
Okay.
Very, very little.
Gautam were missing from our picture. But I didn't see this. Yeah. Oh, sorry. Thank you.
Arjun, 1 minute. Right behind you is missing. Can you please?
Sure, ma'am.
Darbari Lal.
Darbari Lal?
Yeah, look at here. Very good. Yeah, the camera. Great. Very good. Can you click? Thank you so much. Thanks everyone.